Alright, looks pretty good. Getting the right angle of the dangle here. Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and we're celebrating our 700th video today. Alright, we're nearly complete on this project, and we've gone ahead. We're going to be catching you up in a moment on where we're at right at this moment here. But all we have left is to drill that hole there, finish those two blocks for mounting the other tie rod on the other side, and it looks like we're going to wrap it up, minus changing out some stainless steel fasteners. We're still waiting to come in. We have the hinge pin back here, the bushings, and the retaining pin is what we're going to call that. And we're just about there. All right, so here, let's catch up. We got our 4 clevis block ends in the vise here, and we have a pretty good sized Bessie clamp clamping way down at the bottom, squeezing them all together, just because when you got multiple parts in there, you want to make sure that you're making contact with all of them when you set them up in a vise. Otherwise, you're going to lift one out of there. You might crack one of these nice blades. Anyway, we're getting ready to make the groove this will set down into all the way. There's 5/8 on the width there, but we're going to give it a little bit more. So we want to find rough center. Now, there's a lot of different ways that you can come over here and take a straight edge and get the feel of that right next to it. You can also go ahead and just put 2 tool bits in here. These happen to be slightly ground 5/8, so they're a little bit under. They're like 6/15 instead of 6/25. This is 1/4 inch. This is 1.5 inches. So the 5/8 would actually let you come right in here. And the 5/8, you got enough. You got to be close enough so that you're grabbing two surfaces on this side and 2 cutting surfaces on this side on the staggered tooth cutter, and then you're feeling down along the side on each side here, and you can just go back and forth and get the feel. We'll call that 0. All right, we're going to see how close we are, but we're going to come down in there, and then we're going to measure this width and measure that width, and we'll see what we got by feel. When you're starting out in machining, you should always feel your differences on surfaces and things like that, because it's a sense that can be a quick reference, and the better you are at it, the closer you're going to be guesstimating cuts and things like that you need to have that feel for. All right, just food for thought. All right, I'm going to go ahead and Tom Toby Zastro gave me this indicator here, and I'm going to set this up here on my cross slide here, just so I can set a 0 reference point to where we're at right here. So after I make the plunge, then I'll be able to adjust it from side to side. All right, we're going to fire this thing off. In fact, I was in neutral. I try to do, if I'm going to have my hands around here, it's best to have the machine off and it in neutral, just for safety's sake. All right, fire it off. We're not quite sure what we're going to be running, but that's about 93 RPMs right there. All right, we're going to run coolant too, but I don't have it on yet. That's hence all the guards that I have up here, and that's to hold the soup into the machine here. There we go. Okay, now we're going to back up, and we're going to make sure that we actually have our blocks in there tight. Back in neutral. Okay, we didn't hurt the cutter. That was just barely. Just letting you know that you need to make sure that your setup is tight. Okay, a little scar right there is not going to matter. We'll go ahead and clean and reset our vise. Okay, no matter what we do, we're not able to run all 4 of them in there at one time, so we split it. One at this side of the vise and one at that side of the vise. and the equal pressure. I made a slight cut down through there. We're going to step it up a little bit here. We're going to probably crank in, we'll crank in 1/4 inch. We'll see how we're doing here. A little bit better than 1/4 maybe. All right, about 300. All right, now we're going to add in a little coolant here. There we go. Okay, I'm coming across. I'm feeding it by hand here. I want to get the feel of it before we go feeding it. All right, that's feeling pretty good. All right, let's see how it takes this other one here. Okay, that feels pretty good. All right, now that we have a little bit deeper on the cut here, I just wanted to go back and just double check, because with a little deeper we can be a little bit better on our feel. 625, 616, 625, 616, 617, somewhere around in there. So we actually are a little bit off on this side here, or off to this side here, I should say. We're a little fatter on the back, but that's we're not going to pay attention to that right now. We're just going to go ahead and go down to our next depth. So let's bring it back to the beginning, and let's take our pocket scale and let's find out how deep we are here. Okay, we're 450, and all right, there's another 1/2 inch. I'm just gonna feed this about 1 inch a minute here. Speed that up a little bit. There's 1 3/4 a minute. Okay, we're 900 deep on both of those, and now I'm going to go ahead and I'm going to side shift this 5,000 just to make up that 0. We were roughly about 9,000, 10,000, somewhere around in there. So there's 5. So we cranked over 3/16. It's going to be 3/16 plus some, but we want to see where we're at first. All right, so there's the full depth at 3/16 on the side there. And then we'll come and we'll do the other side, go all the way through, and then we're going to continue down after that. I just want to make sure that we're removing most of the top side material before we get down into the thickness in the vise grab, even though I think we got plenty of material there. Okay, I took the vacuum, cleaned up this area right here, and that just fits in there. But we do want to have some side-to-side clearance. Yeah, I'm pretty sure there's going to be some powder coating in between there. All right. Let's continue on our depth. We're going to go back to 0. All right, we're over here at Debbie. We finished up the root of our mounts here that our turnbuckles are going to grab a hold of. And we're creating that cross hole. So we got a pilot drill. We're drilling them all too, and then we'll open them up to 1/2 inch. After we finish the root there, we just kind of dress this off. So the overall length, the depth are all set. They're all equal to all of our parts. And now we're just going through and drilling them out. We're using Colin's vice stop over here he made for us. We are loving it. I know all you can see is the top of it and the top of this mount here. All right, now we're going to come through with our 1/2 inch. Okay, it looks to be a tight hole. That's good. I like that. I've gone ahead another step and from where we're working at right now. Right now we are setting up these in the lathe, and we're cutting this register and this thickness down here to weld these in place. All right, and so anyway, I outlined this radius and I hand sanded that into the part there, and this is what they're actually going to look like. All right, so let me bring you in. We're going to actually show you how we're setting up and we're cutting out this register to locate them. Okay, yeah, I believe it. That's the way. You can't mess up with this. What we did is we can't get this down inside the jaws long enough to go ahead and make 4 equal contact points out here close to the grip there. So we use the jaws are stopped, so we know that that's stopping. So all of our depth is going to remain the same, and we just came in here and equally went side to side that way and side to side this way, 4 pointed. We didn't really set up an indicator. We just put our pointer in here. And we gave it a pretty good eyeball. All right. That's within about 5 thousandths right there. now we're pretty snug. We don't have to make it super tight. This fore jaw is in nice shape, nice and square, and the jaws are really nice and square, and our parts are uniform. So that's going to spin up pretty nice. Let's take a look at it. All right, our travel dial or our readout is all set. So pretty much all we got to do is we come in and face it off till we get to a 1/2 inch, and then we face off another 1/4 inch down to 3/4 inch of diameter. It's pretty simple. Okay, we're coming in, making our diameter. We got one more cut after this. It's about 275 on the wall thickness there. We rough it down to about 0.7978. Then after that, we make a couple cuts coming in by hand. All right, here will be our last depth here. Okay, now we're going to come into our 750 and face that right on into our corner. All right, very good. There we go. And we take our old guessometers and well, they say we got 15 more thousandths to go there. Just for general purpose here, I'm going to check with another pair. Yep. Okay. Better to have too much material. Better be looking at it than looking for it. There we go, and that there's still enough break on that right there. That looks good. There we go. Next. Okay, we shaped out this radius right here and kind of rolled this over. Afterwards, we massaged it a little bit with Scotch-Brite, but we pretty well shaped all of this out on the Wilton. It cuts pretty fast, so it's just kind of simple. This is 1.5 inch diameter, and we're just taking a piece of 1.5 inch here, and we kind of hold it flush with the end here, and we give ourselves some guidelines. The rest of it's all by eye. Just like that. All right, we got these two prep. All right, I put you to where you're looking at this mast 90 degrees from facing forward and aft. And you can see how far back these outreach components right here spread out and how far they angle back. So the first thing we're going to do is we're going to pick our hole dimension on this line right here and kind of hold this up into play here, and that looks pretty good. Everything is going to be off a little bit from each other, but the block is going to angle up like that. When we get the holes done, we'll actually see the final dimension. Now, the reason why we're going to do this hole first is because we're sticking a 1/4-inch slug into that hole. So that means this hole up here is basically going to go a 1/4 inch there. We have our threads sitting where we want them optimized as far as in the center of our travel, which we can have center or mostly inside threads, but we want to have that full adjustment capabilities and the optimum strength on that. And I kind of like that position right there. So I'm going to mark that right there, center. All right, now we want this whole location on the other side. We already know that this horizontal line is set up from when we did it on the table originally when we did our split line. So I'm going to grab, with the tape measure, I'm going to grab that loop up here, which is going to be the same distance to this spot on the other side, and we'll be able to just grab that just like that. I'm going to say that's 28 and 3/4. 28 and 3/4. And we're going to go ahead and center punch that hole. And I got that 3/4 right at the beginning of that line right there. Right there. All right. We're going to go over to the other side and we're going to mark that same position there. I'm going to pull this apart and we're going to go put those 2 holes in there. Come back, assemble it, and then we'll be able to put the holes in on these pieces here. Once we've got that, we'll know exactly where those are at. Then we got it fit exactly the way we want it. We got our mast set up here on the Bridgeport. We have a disc underneath the flat surface on the other side that mounts the cross members, and a toe clamp with a nut on it here. I have a screw jack under on this side here with the pressure from the toe jack there. I don't really see anything else needed in here. We're not going to be putting that much pressure on here. We're only putting a little tiny hole in here, like 3/4 inch diameter. And we're just going to go ahead and zero in here on our mark. Okay, that looks good. Now, this is going to be a 3/4 inch hole, fit that. And we know that this is going to actually set flat on this surface right here, and we're kind of rolled over there. But we're going to be giving it clearance, so we're not really looking for this to be a tight fit. It's a location fit. And we know we're going to be swiveling it like this till we get it right, and we'll kind of grind just like we did in the rest of the area there to give us something clean to weld to. You see, this web right here is actually, it probably runs right about there, just inside our hole right here. We're going to just poke a 3/8 in here, and then after the 3/8, we will probably put a 3/4 inch end mill in here. We're at a roll, so there's no way of getting around it without getting a real short drill or center drill to, if that whole location was that important. This end mill is not going to care one way or another. We just picked 3/4, and 3/4 happens to be the size of our slug, but it also happens to be the size of our straight shank for our Albright shot. Alright, might be a little tight, let's see. No, it looks pretty darn good right there. Excellent. We do want to round it out a little bit. It's actually showing it's tight. I mean, it does hold it tight enough to make it really tight here and kind of open over there. I think we're going to want it to roll, so it's like 50-50 on there. So we'll go ahead and we'll take it rotary burr and we'll just kind of massage that a little bit, more or less like an angle on the bottom on that side and maybe a little bit over the top on this side here, and that'll let it roll over without really opening up the hole too much. Okay, let's flip it over and we'll get the one on the other side. All right. These are our two pieces we had in there. We stuck them in when we left. All right, they fit pretty snug. Right. See how this does. That fits in there pretty snug too. All right, so I can let that in kind of be, and I can just kind of hold up this and work with this one right here. Now, here's something to think about. We're a 1/4 inch off of here. We're trying to maintain this. It's not super critical, but you want to make the best guesstimate that you can. This is just a line of 90 to this, and that's how that's going to swing pretty much in that direction there as it comes up. So where's the center of our hole? Well, the center of the hole is not going to be the center where it's at now, and it's not quite going to be the edge of that. So I'm going to kind of go halfway between the two of them, half between the center and there. Okay, we're going to just say that center and that there is the leading edge. I think just halfway in between those 2 points right there, right center of this. So I'm going to put another line where I think is center. We're just going to draw this out. That looks center there. And halfway between there and there. And we're going to duplicate that on the other side over there just by measuring that side and this side on the bottom. And we're going to put a mark over here that we know that we're working on the bottom, because we would hate to drill one on the top. Left and right. All right. We'll go get those done. Leads over here. We've got these fitted. We put a clamp on this one here to hold this one flat, and we used the turnbuckle to hold this and push this in so that we had it flat here and here. We were able to get the angle, the dangle right on both ends. They face in line of the actual push of the ball joint at each end. Looking really good. All right, our ground's on. The bungee cords were to hold them up originally, and I just left them right there so that they hold that same tension right there, kind of where I wanted. And we're going to switch over to our welding helmet, and we're going to get some tacks on here, and then we're going to lay this down, roll it around so we get a good feel on our weld. I have to laugh because coming down to the last part of this job, I'm actually coming down to the last part of my argon and my helium bottles as well. Here's a shot of those. All right, those are my last 2 bottles that I have a lease with air gas, and I'm dumping them, and I'm picking up New Bedford Welding Supply, and they've been treating me well and delivering fine, and a better price on the lease, the rental of the bottles, and the service is pretty good. All right, let's go ahead and put a few tacks on here. Okay, we got this set up in our grounds here, and we're going to hit that one. But these set right on there. Nice. They look good in the center. All right. We're going to weld up these two here, and then we'll weld up these. We'll let them cool, and then we'll reassemble the thing. And other than trimming a couple bolts and making a couple retainer washers for our pin, we're good to go here. Oh, I like that. I got a straight edge on here. This one here was our first one we welded up. It's still a little warm. About a 1/16 under each side. You could rock this about 1/8 of an inch here. So that has pulled it right here, and this is going to be sitting out here. We're going to put it in a press with a foot under here and under here, and we'll take that out till we get a good straight edge across here again, and that should be fine. All right, one more to weld up here. Okay, there's our tower. All right, we're ready for our final assembling. Our fasteners we were waiting for came in. We made up our Delrin bushings. I just pressed those in there, and we got this one to fit in here. Now, they push in pretty easy, but this has got to have powder coating on it, and the powder coating is going to contract that a little bit, and the bore is going to contract a little bit. So right now we have a pretty loose fit on the pin, but it will tighten up with the powder coating between the bushing and the aluminum itself. Now I got one more piece to do. I did this one here the other day. What we're doing is we're putting a ring of this really good shrink wrap tubing that I used in on my Porsche wire harness. It's nice and flexible. It's a good diameter, but it does come in quite a bit. The whole idea of this is and I created a bar here so that when you undo the knob, it'll rest here. And I want to put something softer than the powder coating so that we don't break away that powder coating within a few hits. And of course, it's how gentle you operate it as well. So the first thing we'll do is we'll go ahead and we'll do this other one here. This shrink tubing surprisingly can reduce its diameter from that to around that with a nice tight fit without lineal shrinkage. In fact, actually I cut a piece and I thought it was going to shrink in the lineal fashion more so than it did, and I had to cut it off because I actually had excess on there, and it's almost barely any extra length. You can almost force it in there, in that little area there. All right. It don't take a long time either with the good heat gun. Okay, that feels like it's in all the way around. All right, we're done with our heat gun. And we're done with the material. All right. The next subject I want to talk about as far as assembling stainless steel with the aluminum products is a product called Tef Gel. Tef Gel comes in a couple different containers. You can look up it online. Ultra corrosion resistance. I was introduced to this several years by my best friend there, Vince. And when you're assembling towers, pulpits, and a lot of different marine applications where you're mixing stainless and stainless or stainless and aluminum, and it really comes in to play when it comes time to disassemble it. And lots of times, especially stainless with a stainless steel nylock, you'll end up creating a welded nut on the piece of material without putting anything on it. So adding a little Tef Gel, I kind of like, there's tubs, and you can dip your finger in there, dip your bolt in there. There is like a syringe type thing. They even give you a little brush that pops in here if you want to use that to get in and out. But most of the time, just a little, you know, I can just hold it in my palm and squeeze just a little bit here. I'm going to go ahead and put a little bit on my stainless. Well, we're going to do the other one. I'm going to have to go clean that. I got grit and everything else in that tray. And I don't want that in on the threads. Okay. Got a good start in here. Alright. Now, we'll put on our keeper. Now I could go over and put that in a lathe and hold it in a 3-jaw and really tighten it, but there's no need for it. Alright, so we'll be ready to assemble the pin, and now we can lift our tower up here and put that in, but we want to have a knob ready to go on there. Now, the joints that I made go in here for the knobs, I also drilled and tapped them for a retainer screw. And that retainer screw, I'm going to also put some Tef Gel on it. And I'm just putting it on here so that I can get it introduced into the threads here. And I can actually see it and everything else before I get the knob on there. And you can rotate the excess right into the bore. The threads will push it in. The hydraulics will spread it around. Alright. So that's set ready to go there. The knobs themselves are stainless, and these ball joints or tie rods ends are also stainless. Now you saw those spinning freely up and down there in that one little video segment, but it's not necessarily how they're going to operate. But we want them to always be free. This stuff is like honey. Alright, I'm happy with that. Now, to go over the top and hold that down, I also turned a pair of Delrin washers, which we'll be putting on here, like that. Alright, now we have Delrin washer here, which will keep the paint from chipping and galling off of that surface. And we have the shrink wrap tubing, which is a good quality shrink wrap tubing. It's pliable, rubber, flexible, and that. I cut 2 studs or bolts just a little bit because it's this ear that I made here is a little bit less than the other ears. Those will take the 2-inch bolt, and this one here I just trimmed down so that I don't have excess thread sticking out. 2 2 to 3 threads, something like that. One to 3 threads. It's about what you want outside your nuts. And we're using a nylock nut on that as well, so that things don't vibrate loose, and you don't have to really torque these things down so they're not rattling and they're secure. All right, and we're going to go ahead and we're going to tap gel that as well. Now this is for the threads. It's not necessarily doing this for that bore right now, just for the threads. I'm just going to kind of push it into those threads right there, and we'll take our knob. There we go. See, that sounds a lot better than clanking like that. All right, I'm going to go ahead and I'm going to tighten that down. 1 tightening, 2 tightenings, this thing's going to be taken back apart and then reassembled. I need to put this thing together because I need to test the strength of the 2 stays. All right, we got our tower here. We've got both of our knobs in here ready to go, minus putting the keeper screws in it. We're going to do that once we have this upright. All right, now we can put our pin through. We're not going to lubricate the pin with any kind of grease or anything else, just because we don't need to spread the grease around because they don't have the painting done yet. All right, we're going to go ahead and spin these 2 knobs up here. All right, we cleaned off that 1/4-inch Allen that we dropped earlier. There's the washer. And of course, on final assembly, you can put an Allen in this side and an Allen that side, cinch it up. When you go to remove it, whichever one happens to break loose will be the one, and then you can slide it out. It can move out either direction. These 2 screws right here are going down in here. They don't have to be really torqued because you're bottoming them out, so you just want to barely get them there. That's it. They're not gonna vibrate out or anything. That's pretty much it. When you loosen this knob that holds the mast, it only lets the knob come up so far, but it also doesn't let it fall off the boat. All right, and you just needed that little bit of adjustment to go from hinge, unhinged. All right, now that we've got that set up and it's all nice clean little package. All right, we're going to go ahead and put our struts in here now. Now, we tacked and we welded in our ears. After we did this weld around here, these stays became arced because of the amount of contraction on this side here. These are cast. This is cast. This is cast. This bottom piece might even be cast aluminum. This welding went on and it was really nice and clean over here. This welding around here was kind of dirty. Kind of led me to believe that this was porous cast or less quality than this one here. Regardless, I treated this one the same as this one, and when I pressed the arc out, it snapped right across here. So I took it, put it on a straight edge, strong back, all perfectly in line, and I V'd that out all the way around. Re-welded it, redid the one weld bead on this back side right here because I had to grind that away to do the repair where it cracked. Then I put it back in the hydraulic press, and then I pressed it straight to match this one here. And as soon as we put these struts and everything else in here, I'm going to take this 24-inch pressure wrench and we're going to put it on here, and we're going to torque this up and down to prove to ourselves that we have a quality repair, but also the integrity of what we're trying to do here by stiffening this up. He wants to put bigger antennas, like more horsepower, bigger antennas, talking farther. You know, it's all part of the program. So we want to ensure that he do that. So let's go ahead and we're going to do the same thing. We're just going to put some Tef gel in on our threads for our eye bolts. We have jam nuts going in on there's right and left hand, so you'll be able to adjust the tension between these 2 points. So if you had to pull one of these off or whatever, there's not a 100% perfect position to go back. You tighten up those there and you compensate here, and it's good to go. There was a rubber gasket that they had in between here, and so that little rubber gasket or another replacement rubber gasket still kind of lets you adjust this, and you can keep your stress relief support. That's what it's about. All right, we're not going to cinch down and lock that down real tight, but there's enough in there that they're not rattling around. Okay. Now we're going to go ahead and do our little test. Antenna mounts in this socket and in that socket over there. This is bolted down to the deck. Of course, and if I'm not satisfied here, I can take it in and bolt it down to the mill top table, and then we know that it's rock solid. I take my big 24-inch crescent wrench here that actually grips top and bottom of the antenna mount, and I'm going to hold this down here, and I'm giving this a twist action. We know the inertia on those antennas are going like that, and this is only held on by 4/4 inch bolts here. This is kind of overkill for this here. This is just basically to take some of that load off of there, but with a little pressure there, and then the same thing on here. Now, I need to feel confident that my repair is sufficient, and that's what it's all about. So the next thing I'm going to do is take this in and go ahead and bolt it down to the K&T and give it a little torque. I want to see this is rubber mounted, so if I can see a slight little bit of motion into this joint that's tight, and so if I'm moving that with this crescent wrench out here, then I'm surpassing the original design in my mind. All right, there's little rubber washers that are underneath these things, and just kind of working back and forth on them here, and I think I'm sound on that. I did this side already. I kind of just gave you a little bit of upward pushing. All right, there's sound. All right, time to go get the crescent wrench. We are bolted down solid to the table. We kind of put it in this position because these kind of overhung this way in the other direction, and we need to get a hold of these and give a good torque. What we're going to look at is giving this torque here and kind of looking at our joint right here, just kind of making sure that we're going to be stout on this thing, without a doubt. Stout without a doubt. Okay, we got the big crescent here, and I can feel that joint to start move and that flexing right there. And come over here to this side. Okay. I'm satisfied that you're able to put enough force on here where you start moving this joint around here, and I've got this down tight, and the rubber gasket's not even in there. There's two rubber gaskets that were in there. They one came shredded, the other one is around here somewhere for a pattern, and so the installer can get that done. We're happy with our repair here. It's a shame that this casting here, I know this casting is more porous. In fact, actually where I cleaned on around here, you can actually see areas that I didn't even weld. It's got pinholes and pockets and stuff like that in it, and where I cleaned up around that one, there's not. So it just happens to be a weak casting, but I believe it's going to be strong enough, and we're good to go. All right, until next time, get her done.